Yes, sir. We'll start, sir.
Yes, sir. So good afternoon to all. Welcome to 5 days FDP program on artificial intelligence and blockchain application for food and agri sector during 24th of Jan to 28th of Jan, organized by the Indian Institute of Plantation Management and sponsored by the Atal AICT New Delhi. And today afternoon session we are going to be handled by our resource person, Mr. Om Routray, SourceTrace systems, and going to be talk about AI and based remote sensing and blockchain application. And before that, I just give brief about our resource person. Currently, sir working as a vice president for marketing at SourceTrace system and worked on food and agri sector. Summarizing, specialized in agri-tech and knowledge management and community building digital marketing. Yes, if you look at the experience since 2019 onwards, working as vice president marketing at SourceTrace, and many companies you worked some other challenging positions, challenging decisions taken by, like act as a managing social media efforts on the company across all platforms, proposing and implementing social connectivity. Basically, it's think about the techno related concept of how good background of our resource person, make use of our resource person utilization in this session. I would like to recommend, I would like to give this session hand over to our resource person. So session is now yours.
Thank you. Thank you. Okay, so thank you for the introduction. I guess I'll also introduce my colleague, Dr. Vijayasekaran, and give the a little background of. So I'll be talking about blockchain, and Dr. Vijayasekaran will talk about the AI and ML part. He is our remote sensing head, so I'll go first. I can also see that there has been a few sessions before on blockchain and AI ML. So I guess all my life I've been hiding for teachers. So it's really funny that today, doing a session for teachers. I don't know about you, Vijay, but this is probably the scariest session that I've ever done. So what I'll do is, we all know that how boring classes can be, especially if they're online. And I can't see who is sleeping, who is not there, etc. So I don't know how the last sessions have been, but I guess it'll probably help all of us if we can keep it a little interactive. So anything, anybody who wants to raise a hand or just speak about how the last sessions have been, and if there is any part where you would like us to focus on, Vijay and me, that will probably help us in focusing on a few sections more. Yeah. No one who wants to speak, interact.
Yeah, they will normally type it in chat window, sir.
Chat window, sir. They will chat box. They will type it, sir.
Yeah, if you want to unmute yourself and you can talk to our resource person.
So requesting participants. Yes.
Good afternoon. Yeah, right. I've got.
Send it to Will.
Good afternoon, Mr. Om. I mean, we have been, whatever the sessions we were going through in the past. I mean, this 2-3 days, we have been looking at all the AI and blockchain, how that is going to be applied in the agri line. And today, actually, 2 sessions were fully focused on the remote sensing and as well as how AI is being used. What is that which we probably, or I probably wanted to look at it is, how do you identify the problem? For example, there are different business case scenarios are there, right? And there are a lot of solutions we can actually provide. Sometimes it can be a normal solution, but how do you identify saying that, okay, this is the problem, I have to solve it only with AI blockchain, I can't think anything else? So how do we, as a company, right, how do you determine that? That is what we wanted to know as a faculty, because we wanted to pass this to our own students. Thank you very much. That's a question I have.
Thank you, Dr. Nazum. So we can actually do this, right? So because you have already gone through a few classes, we can probably chat for 10-15 minutes, see what are the issues that you want to answer, and then we start with our session. If that's okay, that's how we'd like to proceed. About your immediate question, I think, about blockchain, I'll answer, and I'll ask Vijay to talk about AI/ML. Blockchain, I guess the technology has been in spotlight for 7-8 years now. I've been hearing about it since I joined the tech sector. So you will believe that, most of our queries or most of the businesses that come to us will actually be asking for blockchain. That's not the case. Nobody comes to us saying, I want a blockchain. Nobody comes to us saying, or even recommending the technology. I mean, most of our customer communications till the last moment are about how do you solve a problem. In very few instances, once you're talking about, finances, project implementation, etc., then somebody can say, will my technology have blockchain or not? But so far, nobody stresses that I need blockchain and only that. So in terms of our customers, if you look at, the technology, yes, everybody talks about it, but project-wise, this is not a baseline yet. From there, I'd like to say that how do we decide is, for example, let's say right now we are doing a project in, it's a World Bank project in Uganda. So all the agri inputs that are imported into the country will be done by our platform. So what you're going to do is track the agri inputs that will be imported into the country, oversee the distribution as it happens to each farm and farmer, and then put all that data on a stack. So that project, when you look at the scale, the number of stakeholders, the complexities, and also the multiple steps, right? A whole nation's input coming from multiple providers going into each district. So, and then you're also looking at who are the data users. So when we look at the data ecosystem, we see who is going to create the data and how many people are going to share it. So you need to have control on the data upload. No matter how big or small the project, if the data upload is only going to happen by 3 people and I have complete control on those 3 people, in that we do not recommend blockchain. Only when you have multiple stakeholders, your complexities, and you have uncertainty about is the person who is going to upload the data, will that be accurate? Is his intent right? Will he go back and tamper with the data? So people who have access to editorial rights on the platform in terms of data, if that is in complete control, then we say don't go for blockchain because it will raise your cost. If that is not in control and the number is too huge, to physically monitor, that's when we say blockchain. So complexity, number of users, data security. Any sovereign project, government projects, we recommend blockchain. So, but basically these are the 3 determining factors. Okay, so I'll look at chat. Anybody who wants to come and voice, ask a question or chat, both are okay with me. Vijay, you want to say how do you recommend AI or ML?
Yeah, so from the question, what I understood is how we identify the problem and how we solve it with technology solutions. So basically, SourceTrace, we have a very long association with farmer base, and we are working right now in more than 37 countries. So with farm digitization, like the solutions we try to bring in is to complete farm gate. We are trying to digitize the complete farmer value chain. So as and when we have this field level interactions with farmer and also our farmer cooperatives or even agri businesses, we are trying to get this repo with them, like what are their needs and all, like as and when the new need arises from the field, from the farmer level. Sometimes it comes from the customer, the farmer who needs a certain type of solutions. For example, the farmer wants to understand the weather alerts in case of any severe climatic events. Before like 30 days or 15 days, farmer wants to know when it's going to happen. So that kind of a solutions, the need arises from farmer level. And sometimes agribusiness customers, they want to know which are the, for example, if some farms are ready to harvest, they wanted to send the team to, focus on the certain packet of farms. So all these things comes, with our long association, and also we try to understand from their need. So once the problems are identified, like we bring in the solutions from various technologies. Maybe probably Om will walk you through with different technologies, SourceTrace, implementing, to helping the agribusiness partners and smallholder farmers. So from that, remote sensing and blockchain is also one of the major solutions we provide to our customers. Yeah.
Thank you, Vijay.
Yeah. Thanks.
Yep. Anyone else wants to go?
I have one question. So how the SourceTrace contributing for sustainability, net zero, that carbon footprint, and are you doing that kind of project also for government, or only focus on farmers level and agribusiness company? Anything related to sustainability angle also companies are focusing on?
See, sustainability, we do multiple things. I mean, you said carbon, I'll come to that last.
Okay.
So sustainability has, that's part of a tagline, in fact. Also because, I mean, we started working in the global south. So out of the 37 countries, 32 are in global south, mostly in Africa and Asia. So when we look at sustainability, we also look at sustainability in a broader, in a broader scenario. From child labor. So for example, let's say in Bangladesh, there is a fashion brand which uses a solution to kind of monitor child labor. We have a palm oil client in Indonesia where it looks at deforestation. So, because they export the oil, so they have to prove that the oil doesn't come from deforested land. Then, right now we are talking to a few universities in UK to talk about the modern slavery. We have worked on child labor, but I guess we have to take that beyond. I mean, even in India, I guess there are a few research scholars who are working on modern slavery. Funded projects are yet hard to come by in India on these topics. And these topics mostly, the client doesn't invest. You need to have a sovereign or a third-party founder like a World Bank or UNDP, etc., to invest in those funds. So the projects, again, in Africa, we are working a lot on supply chain losses. Farmer incomes, small farm incomes. So those are also sustainable features if you look at the broader new definitions of sustainability. Carbon, I guess, I mean, apart from a few big companies, nobody has exactly yet figured out how to do it. We are currently in talks with two different stakeholders. One is more advanced. That's in Malaysia. We're talking to a aquaculture company. So who plans to kind of produce the fish meal on site. And that's how we'll do the carbon trading. We'll calculate that how much carbon points you're saving by not importing or not shipping fish meal from one point to another. Then we are talking to a few sugar trade bodies in India, in Maharashtra, to work on kind of a waste reduction, carbon point, etc. Still very early stage. We're only done project outlining. We'll still see who the stakeholders are, how do we get the money, etc. But those are the two we're talking about.
Thank you, sir. I think we can have a lot of collaborative work. Maybe talk to you, sir. Maybe some giant funded project with the IAPM.
Absolutely. Yes.
I have another question, Mr. Om. For example, see, because now recently for the past 5 years, I'm seeing that there's a lot of companies are getting into agri-tech, applying the technology to the agriculture. So do you think that there are enough companies now and this agri-tech is slowly becoming a red ocean? Or you think that still there are so many problems to be solved? Or do you think that the agri-tech is still it's a green ocean, or what is that? So that's what I wanted to know actually. Yeah, thank you.
See, I guess 2 days back, there was another session where you're talking about this, saying, will this be the decade of agri-tech? I mean, the funding is going through the roof, etc. See, when we look at a tech sector, we kind of compare it year over year, right? Because when we started, I guess 2 years, even 3 years back, there are roughly 200, 250 agri-tech startups. Right now, we are saying the government and other agencies put the figure at 2,000, etc. But I don't think that number is, if you once you start validating that technology and say how many are there, the number has doubled. I mean, I'll say the number right now will be around 600. So if you look at the sector, yes, that jump is huge. But if you look at the problem statement and then see, are 600 companies enough to you look at any niche sector and you see out of 600, how many will survive after 5 years? We're still talking about unicorns, etc. But I'm just saying all that debate apart. The problem with agri-tech in India again is, there's so few pan-India players. Unless you are a marketplace, unless you are buying and selling. Even in buying and selling, I mean, now companies are slowly going from one state or region to another. So most of these technology companies, the amount of money that you need to go from one state to another, for a drone company, let's say, for an IoT sensor company, even for AI ML, I mean, how many states are actually putting money into a AI ML startup? And practically speaking, there is no business out there. I mean, there is not, even if you put the number, everybody puts the number at some 24,000 crores opportunity and all that. But if you look at the actual revenue that a tech company can run by freely available projects, the number is still very small. So the numbers, the projections, etc., are supremely stretched, very optimistic. But looking at ground, I think we haven't even started scratching the surface, right? We'll need much more startups. We'll need much more. I mean, and still very experimental stage when we are looking at business scaling. Launching a startup is easy, but surviving the first 5 years, I mean, where is the money? So the sector still has a decade before it matures. So, yeah.
Sir, are you working with the farmers, producer, farmer cooperatives also, sir, for providing their services?
We work with a cotton growers, kind of a small farmers body,
Okay.
Chetna Organic.
Okay.
So in other cases, use cases in India, we work with the Haryana Horticulture, we work with TNPL, the Tamil Nadu Paper Pulp Limited, and most others are MNCs.
Okay.
MNCs who source a particular ingredient from India, be it chilies, be it jasmine, turmeric, etc.
Okay. Is there any challenges to implement this kind of technology in FPO levels of farmer producer organization? I'm doing one project also. So what kind of challenges they are facing to implement this kind of technology, blockchain or AI technology at FPO level? As per your experience, what are the major challenges?
Be it a big company, be it a FPO, I guess the concern is, while we would like to co-invest, kind of make it easier for anybody to adopt our solution, that is the cost. Even a big company, when they come to us, they say, okay, no, do I need traceability? Do I need farm management? How much will I save by implementing this technology over 5 years? So all that calculation happens internally while we are talking to a company. I mean, either they do the homework and then come to us. And even then, when they see what will be the actual project implementation cost, most of them have second thoughts, right? So for a FPO, it's way more complicated because you don't exactly have revenues. A company still has revenues and think, where do I get that money out from? So we kind of advise most of these new hydroponic or farm aggregation companies that you have a marketing expenditure, you can probably look at technology adoption under that, because technology can also be a part of your marketing storytelling. So that is some kind of a budgetary jugglery that these companies can do. When it comes to FPO, you don't have that bandwidth. So who pays? So the government pays some 10,000 rupees. So technology at a FPO level, again, aggregation, how much produce do you have at a FPO level? Even if you sell it at a premium by using that technology, will you be making enough to pay the tech company and all the farmers? Third, unless you're into export or, if you're into mango, spices, vanilla, it's some kind of a cash crop where the margins are there, but you're probably losing market segment because of competition, or, your importer is talking about new regulations and they will say they will not take produce from you unless you have traceability. So those are the compulsion scenarios where you can probably look at not exactly FPOs, but a group of FPOs if they're in the similar commodity. But FPO per se as a unit is still very difficult for any tech company to approach.
Thank you, sir. Thank you for your input.
Okay, but so far it's just two of you. I mean, all of you are teachers, so you know how you feel when you go to a classroom and you say, anybody with questions and everybody goes to sleep.
There are almost 60 people are here.
If nobody wants to interact, we'll just start with the PPTs.
Yeah, Kalai Chelvi madam, any questions?
Thank you, sir. Good afternoon. We are listening to your discussions or your conversations. Okay. So here my question is, if a model developed for a particular region, can we apply the same model to other regions also, like crop management, identification, like that?
Vijay, you want to take that? I guess that's a more interesting question for you.
Yeah, I think Vijay.
Yeah, thanks, Dr. Kalai. So, can you repeat the question, please? So, you are talking about the model development in particular to the.
Because here all our AI models are data-driven models only. So we are collecting data. Based on that, we are developing the models.
Right.
So a particular model, for example, for a cotton prediction, something silly related models, can we use the same model to other states and other regions of some other countries? Can we use it?
Okay, thank you.
For the prediction.
Okay, let me explain this. So right now we are also working.
You can understand my question.
Okay. Thanks, Dr. Kalai. Yes, let me explain. So right now we are working for a cotton crop itself for this crop yield prediction using this machine learning and AI models. So basically the same model cannot be used for two different regions. The reason being there are like different agroclimatic conditions. I'm talking about the perspective of agriculture. There is a different agroclimatic ecosystems you might be aware of well known. So right now, for example, we are working in Gujarat and also in Maharashtra. So in this case, Gujarat have a different kind of agroclimatic zone, and Maharashtra has a different zone. So right now, what we are doing is, however, the data, whatever we are gathering from, collecting it from farm level is something more similar. The transactions are very similar. The same model we are trying to develop, but again, the one model which developed for Maharashtra region cannot be extrapolated to the Gujarat region. So it has to be, retrained and tuned further. Yeah, I guess I answered the question. Madam, you are muted.
Unmute your mic, madam.
Sorry, sir. Yes, sir. Okay. In that case, if we have to develop a model in Tamil Nadu, means once again we have to start the work from the scratch. Am I right?
I guess the tuning will be there, but the model base, whatever we have developed for other regions, can be used, but only the data part and the fine tuning, some parameters which work in some region might not work in the other region. So that's where the tuning has to happen. Yeah.
I think some network issues in the screen is freezed. Okay, sir.
Okay. So what I'll do is I'll kind of share the presentation, but any point of time, any of you have any questions, feel free to, stop us, ask questions. So there will be no dedicated question hour. So just stop us whenever you feel like. So, before we, I guess, I'm not too sure how much, has anyone talked about agri data? Looking at the whole agriculture ecosystem, looking at the different kinds of data. And because before we start talking about blockchain, we need to talk about what are the different data systems that you look at and what does blockchain do with that data? Have we talked about that before?
Not generally, generally they talk about satellite data, IoT data, other ground level data, all these things, but consolidated, nobody talks. So far.
Okay. So yeah, cropping was there, right? Yeah. So I'll tell you where we come from. So let's say we started working in 2013, and the parts where we were working for in the beginning was as you can see on the left, the food production systems. So when I say food production, it means, and basically, the stakeholders that we worked with were donors, large governments, multinational corporations, a few farmer cooperative bodies. But the defining feature of our projects in the beginning were large databases. Some of our projects run into 300,000 farmers or 400,000 farmers. And you will be looking at different kinds of data, social history. I'll come to that later. So when you look at food production system, I mean, the data systems can be, the remote sensing data, which is, satellite, weather advisory, pest and disease data. Then you're looking at the farmer data. Then you're looking at farm data, which is soil, productivity, etc. That's another. Then you're also looking at, if it's a government project, then you're looking at biometrics. Any kind of surveys that the government or the company wants to do. Then you're looking at what's the yield, etc. That's again comes under remote sensing, but that's farm level data. Then we are looking at procurement and post procurement. So, what is the crop, what's growing where, which farmer has been more consistently doing good, who is not, who needs handholding. If you're doing any kind of training sessions, then you also need to know where each of those farmer lies in terms of a learning curve. So, our different projects play with these data systems, and every project is different when it comes to, even if in the same commodity, same value chain, and it can be for the same commercial company. But for example, let's say we worked on the Kargil's Cocoa Promise in Africa. That had around 250,000 farmers. So the project was a part of company's commitment to sustainability. So the Cocoa Promise project was to make cocoa more sustainable, give the farmers more visibility in the supply chain, and kind of prove with facts that the farmer livelihoods are kind of being impacted by the cocoa farming. So you're looking at social history, you're looking at livelihood surveys, you're looking at access to toilets, access to school, all that, right? So, and over a period of time in different states, geographies. So I'll just keep checking the chat. So whenever there is a message, I'll try to respond. Okay. Yeah. TraceX has quite a few good use cases. So where TraceX and us differ is, we do more than just traceability. So, and especially the food production part. And the project scales are different. We cannot do very small projects because of commercial constraints. TraceX is still a smaller entity, so they can do the projects that we cannot do. Right. So yeah. So then, the second part that we are looking at is supply chain. So right now, for example, let's say we work with the e-commerce company on, so they have a warehouse, they have a processing unit. So the processing unit, let's say, needs 10 kilos of chilies to turn that into a powder. So they will raise a service request to the warehouse. The warehouse will raise a payment order. So all that kind of interaction. Or also to look at, once the product is harvested and it enters the supply chain, where is it stored, which truck takes it, what happens to the product. And then the last part where also blockchain is more important is we are looking at food consumption. Consumption as in, if you have been looking at the Nordic region, especially how they are working on smart labels. So, it's with traceability, what you have seen so far is, okay, there is a QR code, you scan it and you see where your food came from, etc. But what's already happening in Northern Europe is they have smart labels which legally force companies to share more data in terms of nutrition, in terms of, what are the elements that are there and that are not, in terms of food safety concerns. And also, for example, there is another company in Colombia called iFinca, which is working on a technology where you buy a coffee packet, you scan a QR code, you see which farmer produced that coffee, and if you like the coffee, you can tip the farmer. So theoretically, we can also do the same because we are already collecting the farmer's bank account number and we are enabling traceability. So can we do that on a large scale where, directly not just take the produce from farm to consumer, but also kind of enable that interaction. Right? So I can ask a consumer to tip a farmer or, send a specific request, look at the farmer's, history, to know more. I mean, turn them into a brand, etc. So, in all this, especially when you're looking at the food consumer part, any kind of gamification interaction with the end consumer, we advise that to be on the blockchain. So this is still a evolving, I guess the production is, that's a evolved sector. This sector is still evolving when you're looking at food consumption. So what all can you do once you entered a retail store? So what can a brand do? What can a consumer do? And where does all that data go? So this is where, given that each consumer will be different, will have their mobile phones, they will need data security, etc. This is one system where the system has to be designed on blockchain, right? We still don't have a use case of gamification. These are all theories, and we are still pushing them to our existing as well as new customers that this is where we need to work. But I guess the technology is more advanced than the sector. So nobody has done that yet apart from the Nordic countries. If you look at our solution, as I said, we are probably different from a regular traceability company because we start, as I said, 2013, we started by working on the farm end of things. So I'll probably also pull up a few case studies while we are going through this. So as you can see, this is the kind of a list of activities that we digitize. And each of these activities throws up a lot of data. Right? So you look at, as I said, you look at farmer data, the farm data, then the growth, the agricultural practices. So for example, I'll show you one use case where we work with a US-based spice company, and they import chilies from India. So what they're doing here is, given that the product has to enter the US market, the pesticide, etc., has to be controlled. They have a list, and only that list which the farmer can use. So so the input, the distribution. So we also work with clients where they give financial and non-financial input to the farmers. It can be a loan. So for example, let's say we work with a project with Central Bank of Nigeria. Now the Central Bank of Nigeria works with around 300,000 farmers. The scale that you have digitized so far is 240,000. And what we do there is we capture biometric data. We also capture the loan data, account number, etc. And the moment they come to, when the bank buys back the produce from the farmers, we also kind of close the financial loop. So I'll take you through that case study. Now that's a use case which is ripe for blockchain, because there is blockchain. There is a bank, there is financial transaction, there are multiple stakeholders. And then also the software footprint of that project is also very diverse. There is SAP, there is a e-payment partner. So when you're designing a complex system like this, these are the systems that you want to move to blockchain, because not because of just data security. I think everybody talks about data security when you talk about blockchain, but we also talk about automation. That if you have a really complex process, how does blockchain help me automate parts of that? Right. So yeah, I'll kind of skip through sections which talks more about our solutions. GDPR, yes. So there is a question in the chat room about GDPR. We have instances, for example, the Central Bank of Nigeria project is actually runs from Nigerian servers itself, because most of the sovereign clients want the data and the servers to be within that geography. We also have worked on a few projects where we have installed physical servers in the client premises. So data again, Malaysia again. I mean, the project that we are talking to, we are now talking to a local server partner, and we have to follow a whole set of rules for that geography. So Europe is, as you know, is the toughest. Right now, we work with a couple of European multinationals. So, and the problem is they import ingredients from different countries. So, China, Laos, India, etc. So each of that ecosystem, so how do we refer to each of these installations as ecosystems? So while it's the same client, they import 5 different commodities. So we have to design 5 different commodity ecosystems differently. For a company like us, it's not just technical challenge, it's also a, earlier billing was easy, right? So you have a client and you give them a simple metrics of how your project scales up. Now you'll have to look at, what are the commodities, what are the geographies, what is the process for each. So the pre-sales process for a company like us is now really long because there is so much that you need to look at before you kind of close and sign the deal. So yeah, so ecosystems is what kind of a data privacy, and not just data privacy. I think, also when you look at these different commodity ecosystems, the data is with the data that the company and we deal with are very different. So each of them have to be treated separately. Yeah. So, our technology stack looks like this. So as you can see, the product moves from the farmer to the end consumer, and we have touch points at each of these. This is a very brief overview. Within this, we are trying to do a lot. I'll probably not get into that. I'll show you the next. Okay. Now, a few primary questions about blockchain before we dive deeper. As I said, blockchain is a word I've been hearing for the last 7 years, and I'm yet to see blockchain become a core, a kind of a project criteria. So, as many of us also say that blockchain is a solution looking for a problem, right? So the technology has been tested, the technology is ripe. There are more blockchain experts than any other any other niche technology, but we don't have that number of projects yet. So it's a solution which is looking for a problem, right? So this is another definition, that world's newest solution to the world's oldest problem. Now, what is the world's oldest problem? Who wants to go? You can say in chat, you can say in voice. Farming is not the oldest problem, right? So,
productivity.
Productivity came after agriculture, so can't be. No. Yeah. So trust, right? Transparency, traceability, etc. Those came later, but I guess trust. So, so blockchain, as I say, is the world's newest solution to the world's oldest problem, which is trust. How do I trust what you're saying? So earlier you had sovereigns, you had, when you look at currency, financial systems, there was a central bank or a central government or a kingdom which said, okay, I kind of put my weight behind this system. So when you look at blockchain, what does blockchain say? Blockchain says, okay, we are the problem is the government, right? So what it does, blockchain is kind of a put the whole system of trust on its head. Earlier, you needed a central bank, or you needed a government, or you needed a sovereign. You needed anybody with an army. If you look at medieval to modern age. So all of this, so trust in any currency or any commodity, be it gold, be it wheat, be it actual notes. So somebody with might had to put their weight behind this. So, I'll not talk about crypto because whenever we say blockchain, everybody says crypto, but I guess how crypto came about and blockchain came to be is by distrusting the same sovereign governments, central banks, armies, etc. So when we talk about blockchain, I guess that's what we need to understand, that yes, even commercial transactions. So, so what blockchain does is it says that we don't need a sovereign or a stamp to sign off to gain trust, right? So, and in agriculture specifically, we'll see how that works. Now, blockchain is probably one of the difficult technologies to showcase, because how do I show you is a server technology, right? So there is nothing to see unless you are a coder. Even if you are a coder, I mean, blockchain is not a technology that you can demonstrate. It's a server technology, it's a data storage technology. So what blockchain is all about is data. So what are the data points that you're dealing with when we come to agriculture? So, there is data on produce, right? So when I say produce, it means, and how is that data ecosystem evolving? So we'll also look at that in the next slide. But what I'm talking here is data on produce. This includes the farmer, the farm, and the produce itself. Then data on quality. This is the biggest trust factor, right? So we are seeing that with e-mandis, we are seeing that with the e-Chopal, and now also multiple governments installing kind of a quality assaying solutions. The private mandis are coming up in Gujarat, in Tamil Nadu, which are also looking at making quality, AI-based quality solutions as a part of a mandi infrastructure. So data on quality is one of the biggest questions that we need to address. Then logistics, storage. Logistics is again, I mean, now that we have smart trucking solutions, we are looking at, for example, let's say a product has to be transferred at 18 to 22 degrees temperature. So, does my trucking partner has a truck which has that temperature range? Did it break down on the way? So all that, I mean, kind of how do I trust my logistics partner? And then the warehousing solution, etc. So if you look at this whole ecosystem, you'll also see that on produce now you have IoT, which are soil sensors, quality. So you have these AI-based quality assaying machines. Logistics, you have the smart trucking partners, you have smart warehouses. So when I say blockchain, what you're looking at, we are looking at a platform which can automatically capture data from my IoT sensors, the warehouse monitoring system, and the trucks. Most of the smart trucks now have chips embedded in them to track location. It can also track the temperature and the moisture, etc. So, futuristically speaking, an ideal blockchain system will have each of these data coming into the platform in a completely automated manner, because blockchain, what it addresses is tampering of data, right? That's the basic premise of moving to a blockchain platform, that once data is entered, nobody can tamper with it. So the second step is, if there is nobody to tamper, the data is even more secure. So my soil data is not coming from a soil card or a lab, it's coming from a sensor which is sending the data automatically. So at every stage, that's what I guess, even right now, I guess we are talking to a drone company in UP, which is working on Metacore. So we are also looking at satellite data has been integrated much before. Now we are also looking at integrating drone data into all this. So what are the data points? So for example, let's say our solution has 2-3 interfaces. That is a mobile application that most of the staff, the farmers, the lead workers, so they use the mobile application. That is the management. For example, let's say at the warehouse, the procurement agents, the management, they also have a web dashboard. So the data onto our platform can come from any of the smart devices, the mobile application, the web dashboard. We also import data from Excel sheets, etc. So if you have a ERP, if you're using Microsoft Excel, So no matter what the company is using, we kind of pull data from all those ecosystems. So, that is the first ecosystem data that we import. The IoT sensor is next. Now, let's say, for example, I told you about the government projects that we work in Africa and Bangladesh. In India right now, we are talking about the government presented a draft paper on agri data stacks last year. It's still, nowhere near completion, but I guess, what you're talking about is if you look at a district or a geography, we can have data on the farmer name, bank accounts, maybe not bank accounts to start with unless they're a customer, but the soil health card, etc. So once you have agri data stack, then you need blockchain, because how does a government launch a agri data stack, and how do you control that those with access are not misutilizing, tampering, or in any way corrupting the data? So we'll come to that later, look at that more detail. Then traceability currently is probably where we are seeing most of the blockchain solution being implemented, because again, the money is in traceability, because most of the MNCs, for-profit companies are investing there. So they are the first to move on to blockchain. I think the primer, I'll share the presentation with you so you can go through these slides later. So, the primer I'll probably skip unless somebody actually wants a primer. Let me know in the chat box. So what I'll do is, okay, look at probably a few videos, unless you have seen them before, but so our data across value chain, again, I mean, that depends. Our blockchain is a custom installation, so that depends on what the consumer and the project needs. Right? So, but let me try to share my. Let me know if you can start seeing the video. Give me a sec. Dr. Ganesh, I'm just sending you the link. Let me
put it in chat window, sir. I'll share it from my side.
Yeah.
Just copy paste and put it in the chat window so that I can. 1 minute, I'll share my screen.
Fair trade. Do you know
the video is visible, sir? Sound
that the coffee that you bought
yes,
is actually fair?
Yes, sir.
How do you know which one is real? How do you know that this t-shirt has not been made in a sweatshop with a simple tag added at the end? You simply don't. In order for you to be certain, you would need a record of all transactions and events of the life of an item. That would be possible with blockchain. What's a blockchain? That's a fancy word. Blockchain is related to Bitcoin, the cryptocurrency. Initially, it was made for financial transactions, but it is now revolutionizing the business world, especially supply chain. It's just like
you did, so we can skip it. Yeah.
With regular transactions, there is a middleman like the bank that registers this transaction, a centralized system like Microsoft Word. But with Bitcoin, transactions are between user to user. So when there's a transaction, the information is recorded on a shared ledger or block. And these blocks are linked together to form a blockchain, like a shared Google Doc. Transaction accuracy is driven by the fact that consensus creates truth. In a blockchain database, every participant or node maintains a copy of the shared ledger. Each transaction on the blockchain is recorded in computer code showing who the parties are, transaction details, and timestamp, with each containing the unique math-based encrypted signature. This digital signature is key as it allows each block of information to be securely connected to all the rest. It's this system of full transparency and connectedness that lends the blockchain its trust and credibility. This connection provides an audit trail of every transaction that's ever occurred in a system. So, if there were an unauthorized change, each node is notified and we can see where it took place. They then would agree to recognize the change as valid or rejected. Again, transparency and consensus combine to make the blockchain system virtually tamper-proof. Today, your data is stored in silos, just like a Microsoft Word file. When blockchain, your data will be stored publicly or pseudo-anonymously in a shared database. Now with blockchain, you can track the chronological history of the organic cotton shirt that you bought. You cannot tamper or cheat because everyone using the system is watching you. The blockchain revolution isn't going to happen overnight, but it is expected to change our lives like the wheel did, or the electric motor and the internet itself. I believe that this blockchain would be the next industrial revolution.
So, now see, quite a few promises were made in this video. So between what's possible in a technology and what you actually get when you implement are very different things. Right? And I'll give you a few challenge scenarios. Now we are talking to, for example, it's the Australian meat processing industry. So that is a body that represents the whole meat sector. And it's probably one of the most advanced clients that we ever spoken with. Anything that we could recommend, mobile applications, smart warehouses, IoT in their processing units, all of that. I mean, I guess it's a very rich sector, and they have adopted every technology that's available. So they came to us with a scenario where they said, we send these what is called a prime. The prime pieces are these large animals which are exported, and so it has a QR code, it has all the processing, etc., all the data, right? The problem is when you export logistically, it's impossible to send a million small retail packets. So what they send is a prime. A prime is a large animal. So when they ship to, let's say, China or India, that's the prime that that lands at the shipping containers. And then they have standards of how the meat has to be cut. Let's say 200 to 400 grams or a kilo, etc. And the meat sector has very definitive standards of butchery. The problem is, they said until it lands on our buyers, the first bulk buyer can see and verify all the data. But once the prime is cut, how do you ensure that mixing doesn't happen then? So let's say prime should give away only 10 kilos of meat. What if the local buyer mixes produce from outside? So he said, we can assure a bulk buyer that he's getting the best of Australian produce, but the retail buyer doesn't know that, right? So the moment you walk into a premium retail store and you see Australian beef or New Zealand duck or whatever you see, the Atlantic salmon, most of them are packaged here in India after they have landed. So the meat industry said, we are now looking at potential scandals or scams or corruption, etc. Or maybe, as you have seen with honey, etc., that, sometimes the old bottles are used, or some spurious product is mixed into this, and then there is a court case. So the industry is kind of going ahead and saying, we want to solve this before we run into any kind of scandal. So how does blockchain solve this? It doesn't, because you have already done that. The meat is landing in perfectly pristine condition. So how do you tell your end consumer that, blockchain, no blockchain, etc.? That is not technology to kind of make sure, no software technology that can make sure that the product has not been tampered with. So the meat sector was now looking at, there are two ways. One is either you cut the primes into retail pieces, then the shipping cost will kind of rise. So that will cut into your profits. So do you take that decision? Or now they're looking at meat stamping. So there are these laser guns, which, for example, let's say the prime has to be cut into 10 pieces. So the whole meat will be laser branded. Now, laser guns are probably one of the premium niche solutions that you're looking at right now. Not just for meat, but also for fruits. Because you have stickers, which, stickers are kind of lost any kind of currency they had with customers, because you go to any local market and you see stickers on fruits. So stickers can also be duplicated, stickers can be tampered with, anybody can print stickers. So now you're looking at laser gun. So when you're looking at designing a system which a data ecosystem, then blockchain as a technology can be tamper-proof, but does the blockchain implementation that you're doing for that client, is that tamper-proof, right? So what you're looking at again here is, I gave you one example of what happens after the product lands. Now we look at coffee, cocoa, etc. These are the sectors, vanilla, and we have a lot of clients in these sectors. The problem is these are markets these are premium products. There is enough money in the value chain, and there is also enough pressure from buyers to make sure that the coffee and the cocoa, etc., are socially sustainable, fair trade, etc., etc. So blockchain theoretically can solve the issue, right? So the moment the cocoa is harvested, you tag the tree, you tag each bag, they land in Europe, then you open the packet, pack them into retail packets. Again, you can automate that or do that tamper-proof packing, etc. Now, when we talk to our coffee and cocoa customers, the problem is most of them do not directly work with farmers. So they will work with a lot of aggregators who do the aggregation on the ground. And they have a set of parameters that they say, okay, my coffee or cocoa has to meet these standards. Send it to a lab, give me a report. If the lab report says that you're meeting my requirements, I'll buy it from you. Right? So that is a long-term contract. And you buy at the pre-agreed price. Now, the buying company wants to implement blockchain traceability, whatever the solution. The selling company doesn't want to. Right? And the same thing is in tea. When you look at tea, you look at estate-wise, you look at small producers of teas. So estate teas are easier because all the tea leaves come from one estate. They're processed in dedicated processors, and then you can bag it, tag it, etc. But when you're buying tea from multiple small gardens, how do you do that? So, and you're seeing that not just in India, coffee, cocoa, as I said, in one of the most evolved ecosystems where the software can do the transaction proofing, etc. But when you're looking at actually how the product moves on the ground, there's so many drops in terms of handover. So, a perfect system is still like years away. So what can blockchain do? It can do transactions. We are looking at the agri stack, as I said, be it for insurance, farmer, crop, weather advisory, etc. So that's the whole ecosystem there. Traceability is one, which is a pure data play. Agri stack, which is, as I said, when you have the governments and millions of farmers coming onto a similar the same platform. Stacks are a whole ecosystem by themselves. But Agri Stack is something that multiple countries are talking about now. And this will be a pure blockchain solution, no matter where it is implemented. And then process optimization. Process optimization means automation. So how do I use blockchain to automate parts of my processes? So what we'll do is we'll see. Yeah, so I'll just share another.
Yes, please, sir. Yeah, got it.
Blockchain. Confusing, even confounding. You have a block, then another block, and those blocks contain information. It could be any information, as many blocks as needed. Each one chronologically connecting the blocks behind and in front of it. And when new information is added, any information, a new block is added. If previous information or data is amended or changed, you guessed it.
You can't see the video.
A new block is added. The information in those blocks is secure.
I think you opened the report that I sent you. So
A system that can be programmed to run it. And when new information is added, any information, a new block is added. If previous information or data is amended or changed, you guessed it, a new block is added. The information in those blocks is secure because a blockchain is a digital ledger system stored across a variety of networks. A system that can be programmed to record and track anything of value, from medical records to food supply chain transactions. Most people think cryptocurrency like Bitcoin is the same thing as blockchain, but blockchain is not Bitcoin. Blockchain is the underlying technology that enables Bitcoin, like how an engine can power a tractor or a cargo ship. Let's look at what blockchain can do.
You want to show the report, sir, or is it for only?
no, the report is for reading. I think I just sent it.
Okay.
So I'll probably just share a few resources which you can look at later once the class is over. So one of the first use cases, give me a sec, I'll just, is traceability, right? So probably the easiest one. Now, apart from what, for example, let's say TraceX or us are doing, I mean, there are also much more bigger projects in the public domain that you can look at. Beef Ledger, again, Australian beef trade. You should look it up, read more about Beef Ledger and how it works. But as I said, these are complete sectoral platforms. So you would look at a beef, wine, cheese, shrimp, coffee. So these are sectors where you have enough money, where the sectors are powerful enough, and the sectors want to protect the markets and the penetration that they have, right? So when you look at, I guess somebody asked, how do we define or recommend blockchain? The world over, you look at blockchain projects, you will see the same trend. High value commodities. So, there is incentive to protect that commodity. Second, money. Blockchain is expensive. Even when we do a project between a blockchain and a non-blockchain project, the cost differential can be as much as 25 to 30%. Then, as I said, a complex ecosystem. So each of these commodities are produced through a very dedicated process. They are then, shipped, then the retail buyer, all that. So each of these are global products which move through very complex value chains. So you're looking at capturing data through a complex system, which can be blockchain. This is the system that we designed for the rice exporters, but I'll just probably, skip to main parts here. So for example, they say, I'll show you the chili use case. This is for a company called Griffith from US, and they buy chilies from Indians, the Indian farmers. So, the process that we follow is, collect farmer data, monitor the inspections that happen on the farm through the mobile application. So the extension workers actually go to the farm with the mobile application, take pictures, do farmer interviews through audio, or if that is something that a pest or something, they can also look at. They can also do videos. So we look at also multi-format data. It's text, it's image, it's video. So all that data is imported into the platform. Then the procurement, which involves financial history, payment, etc. Then the processing begins. Then the product goes to a lab. We come back. It comes back with a lab report. I'll show you that later. Then each bag is tagged and goes to warehouse and then shipped. So what, especially, you can see the same process here. So here you see that data, as you can see, data comes from multiple sources. This is data that is collected by the farm extension workers. This right now is done by the warehouse managers. We can automate this once they have smart warehouses. This again is the extension workers. It goes to a lab. So the lab report comes here. They have operations people who manage this part. So they upload the lab report, we scan the lab report, and then get the text. And eventually what we give them is that various kinds of traceability reports. This is one extensive one. Second, this is a QR code that you can also scan right now. When you scan the QR code, you'll see that what we do for them is different batches, the batch quantity, and then the farmers that have contributed to that batch. So as you can see, this is 25,000 kilos. So we also look at the farmers that have contributed to that particular batch. And once you click on each farmer name, they can see the geolocation of the farm, the farmer's photo, crop season, crop size, etc. Then the whole logistical details. Then, as I said, the lab report. And lastly, as I had said before, that they also monitor the pesticides that the farmer is using. So we also track, monitor, and capture this data. Right. Has anyone talked about smart contracts before?
No, sir.
No, sir. No.
So I guess one of the most important things, and there is a lot of, there is nothing to show yet. As with most blockchain things, I mean, this is again very, you probably see this in Bitcoins more than blockchain now, in food and agriculture right now, but smart contracts are something which is probably, I personally am much more hopeful about. So I talked about process optimization. Right? So, yeah. So what are smart contracts? Smart contracts are contracts, but smart. So the moment we say smart, that is a digital angle to it, right? So smart contracts are programs stored on a blockchain that automatically implement agreements or transactions when the predetermined conditions are met. Now, I talked about process optimization and smart contracts. How does it do it? So for example, let's say right now we are pitching to a few of our existing customers that we can look at the whole process and optimize that process by implementing blockchain. Data security, etc. That's basic. Smart contracts are the next level. How? I'll give you one example. Let's say the Bank of Nigeria project that I talked about. So the farmer has an account with the Bank of Nigeria. There is a loan history. Let's say the new harvest happens. The farmer brings his produce to the bank, sells it. Right now we have a Bluetooth weighing machine and a Bluetooth printer that captures that data. So, at the time of procurement, there is no corruption. Now our system already captures that how much produce that farmer has got to the bank, and what is the weight, quality, etc., and how much he has to be paid. So currently how it happens is each of these, the whole procurement happens that is the Excel sheet or a ERP which captures all that data. The ERP then goes to the finance, the admin department. The admin department will go through all of it, will tally with the the warehouse check-ins, then make sure that each of those entries are correct, then send it to the finance to release the payment to the farmers. So what you can do here is with smart contracts, we can say that the contract can be written in code on the bank's platform, that when the farmer brings in the produce and the quality, etc., is checked, which is done instantly. If, for example, let's say the produce that the equivalent of that produce is 2,000 rupees. You have the loan history of the farmer. So the farmer, let's say, owes you 500 rupees. So the smart contract can be written in a way that when the procurement happens, the smart contract will tally how much the farmer is owed, and if the owed amount is more than what he owes the bank, the payment can be immediately processed, right? So a smart contract can be written in code in that way, and the payment can be almost instant. The moment the procurement happens, the machine, Bluetooth machine, captures the weight. It goes to our platform pings the blockchain contract, and the payment is released to the bank, to the farmer's account immediately. Or whatever. I mean, the program will also capture other instances that if the farmer is not to be given money, if he owes you still more money, then what happens? So a smart contract can have all those permutation combinations. Now, what does it do? It facilitates, it verifies. So you set the conditions of what needs to be verified. The blockchain platform will verify that. It will facilitate interaction between the bank, the Bluetooth weighing scale, the farmer, any other stakeholder. This is just one example. And then it enforces that condition without needing any admin finance guy to come and intercede the process. Right? Lastly, what we look at is AgriStack. India currently is talking a lot about this. So we're talking also about health stacks and AgriStacks, all of them together. I'll share the presentation with you. So here what we are talking about is how do you look at citizen services? Now it can be a farmer. When you're looking at health, you're looking at sick people, all that. So any kind of citizen group that you're looking at. Now, let's say health stack, we are talking about that whenever you go to a doctor, the doctor can probably just ask for your digits. You say 6789. The doctor puts in 6789 into his dashboard, and he can look at his your entire medical history, right? So you go to any doctor, any hospital, etc. You just need to carry your smart card number, whatever it is, like an Aadhaar number. So same as health stack, we are looking at AgriStack, where each of the farmers, the farm is geotagged. You have his loan history, you have his product history, you have his yield and crop variety history. You also know who he's sold to, at what price, etc. So now what it does is it brings in the farmer. It can bring in any research organization, any university. So let's say you want to do a POC and you need a certain kind of data. The government can also say a for-profit can come and access the AgriStack. What do you bring in? I bring in my APIs. And the government in return will give me that, okay, what is the data that you need? Give us a proposal. And the government through the system can give us access, right? So I want, let's say, data of all the wheat farmers in Punjab, because I want to procure wheat and I want to connect them with a buyer in Europe. And what I'm selling to the European buyer is this wheat is traceable. I can see what pesticide has been used, etc., right? Transparent, traceable wheat. So I go to the government with a proposal saying I need wheat farmers data from these 3 districts to target to them. So the AgriStack can have any of those combinations. So the AgriStack is, again, you'll see that there's a lot of reports in terms of who controls what access, data security. Does the farmer, same about health stacks, that why do I want my whole treatment history to be out in the public domain, right? So stacks are controversial. Stacks are yet to be, yet to come across a case study in that, but blockchain is going a long way in allaying those fears that I can control my data. If somebody tampers, somebody downloads, somebody wants to change my data, I'll be notified, right? So here, how blockchain will work is you have a number, you have a mobile number which are linked, which didn't happen with Aadhaar, for example. Let's say, if somebody takes a printout of your Aadhaar, you should get a ping. If somebody is putting your Aadhaar for a loan, any kind of a license, vehicle license, etc., address proof, you'll get a ping. So blockchain can do that. Blockchain can design those extremely complicated systems where anybody with access to your data. As I said, smart contracts. You can write absolutely any kind of logic into the system, saying alarms, notifications, etc. How do they come up, right? So Vijay, I guess next. I've eaten into your time, but you have 40 minutes. I can take any questions now at the end of sessions. So you let me know. Yeah.
Thanks for.
The question part is yes.
Yeah. If participants have some questions to Om, or should I finish my presentation?
You just continue, sir. Please carry on, sir.
End of the session, we'll take.
Can I ask a question to Mr. Om?
Oh, please,
No,
please,
absolutely.
please, sir.
Can I ask? Yeah.
Okay.
Mr. Om, there's a we are. I mean, I'm very happy to hear all the kind of use cases you're telling about the blockchain. I have one real worry or question. What is the elephant in the room which we are not seeing in terms of a blockchain? Because if we are seeing all the benefits of it, but definitely like something there might be there, because no technology, if you see it, like, it will be having its own shortcomings, right? So I
told about the elephant in the room after the second video, if you remember. I said the technology itself is foolproof and all that. But when it comes to, when I talked about coffee, cocoa, etc., and I said how the product actually moves, there are significant drops in handovers. The product doesn't move on a software system, right? So there is an actual guy who is handling the package, opening, repackaging it, or putting it on a truck. So, and that's the elephant in the room, right? The software has to meet actual hardware people. So, and that's probably the kind of an innocent view of it. The non-innocent view of it is also malified when there is malintent into the system. We have seen that with absolutely every secure software system designed in the world. If there is malintent, and in agriculture especially, I mean, the opportunities to corrupt data, you don't have to know hacking, right? You have to know the product and the packet. So absolutely innumerable elephants in the room.
Yeah, thank you.
Over to you, Vijay.
Yeah, thank you. So I guess in the previous sessions also you might have kind of learned a lot about the remote sensing and precision agriculture and so on. So from the participants, so I have some slides to give some basic introductions about the remote sensing part, and as well as this what are the applications right now SourceTrace is implementing, and some of this futuristic applications are possible with the remote sensing data combined with this machine learning models. So should I start with the introduction part, or you already have some sort of basic idea about the remote sensing and all?
Yeah, morning we had one session from SatSure. They were talking about remote sensing a little bit. If you want, you can a little bit cover, sir, no issue. But morning we had a session by SatSure company.
Okay.
Remote sensing.
All right. Okay, then let me begin with asking the question from participants, what you understood from remote sensing.
Yeah.
Sir.
Yeah, please.
Sir, they explain some kind of what kind of data we can collect, in what way we can make use for developing those applications. Likewise, they explain, sir. But whereas this A and ML model, they didn't connect it with it.
Okay. Okay, let me just give you a brief kind of introduction. I don't go into the details, but let me give it in my perspective, and will make you understand more about the technology. Because the remote sensing technology is extensively used in the agriculture for addressing various solutions faced by farmers. So when you talk about remote sensing, remote is from a distance, and sensing is acquisition of information. So basically, without making direct physical contact with the object, we are trying to get the information about the object. That's what the definition of remote sensing. So for example, our human eye is an best example for a remote sensor. So here we are talking about, when it comes to remote sensing, I'll be talking about different types of sensors and how the remote sensing system works. So for the basic example here is a human eye that can act as an excellent sensor. Like so, any object we are perceiving, we are not getting directly contact with the object, but we are getting the information from the distance itself, how it is processed in our brain. For example, here, by looking at the object itself, so there are mediums in which we are perceiving this object. That is a solar energy, that is a sun from the light. The reflected light from the object is captured in our eye and processed in our brain. So that is the basic ideology and also the technology behind this remote sensing system. So the remote sensing, when I talk, it is more of deal with this satellite-based systems where the sensor is mounted in the satellite platform that used to collect the Earth information while orbiting around the Earth. So basically, in the one I showed here is a natural. Our human eye is as a remote sensing system. In the artificial way in which here, for example, our target is agriculture or vegetation in Earth. We are trying to collect the information about the Earth futures from a distance. That is mainly from the satellite data. What you are seeing is the reflected sunlight, the electromagnetic radiation that's being captured in the sensor, and it is relayed back to the data station, where it is processed further, and then analysts like me who do this, developing the solutions from these products. So when you talk about the remote sensing systems, there are large number of systems from based on the application and also the level which it is used. It can be classified into terrestrial, airborne, and also like geosynchronous and so on. As a terrestrial remote sensing system, even our smartphone could act as a example for a remote sensing device. Where also there is a large number of in recent days, there is a large applications are coming out with this unmanned aerial vehicles and airborne instruments like the light detection and ranging, like LiDAR technology is also being used for mapping the Earth's futures. And most of the agriculture applications right now, it comes from smartphones. For example, using the smartphones, a farmer can take a picture of a pest affected crop, and he could able to get the informations based on the existing database, where what kind of a pest attack it is, and what suitable the pesticide should be applied, and what kind of crop management recommendations he should take, and all these things could be provided through smartphones. When it comes to the remote sensing with satellite data, that gives us some of the major advantages of the remote sensing system is it has the repeativity, like every 24 hours. For example, this Earth orbiting satellites, which can cover the same region at the same time, like for example, every 24 hours, you could get the same parts, same Earth future being observed. Like so, basically, it is called as a temporal variation, like the temporal repeativity. Every time which comes over the same place, it's take the snapshot, like you're taking the picture from your mobile phone. Yep. So this is a typical example of orbiting artificial satellites around the Earth. What you're seeing here, these white dots is basically representing the different satellites which are orbiting and also collecting this Earth information while orbiting. So there are like more than 2,000 satellites which are operating. This is based on 2018 data, but now it is much more. And India is also a pioneer in Indian. You might have heard about our Indian Space Research Organization. We have an extensive program for Indian remote sensing satellites that's being used for various applications, agriculture, disaster, and also in urban mapping and forestry and etc. So how actually this remote sensing system helps in agriculture? So basically, Earth Futures has the reflectance property. That's how we are seeing the perceiving the objects through our eye also. So right now, what you are seeing here in my screen is basically the reflectance property of different Earth Futures, such as soil, clear water, and vegetation. So basically, you might be well aware about the electromagnetic radiation, where the visible, near infrared, and short-wave infrared are the major spectrum. But for a human eye, we could able to see only the visible spectrum of light. Where in the case of the sensors which are designed in remote sensing systems that could capture even the near infrared, short-wave infrared, and also even the radio waves. There are sensors which are capable of capturing those radio waves also. So how this helps? In visible spectrum, the reflection would be of very short. For example, our interest here is agriculture, that is vegetation, where you can see in the green portion, there is a small spike here. What you're seeing is a reflection. That is the reason you are perceiving the vegetation as green. In the green light, there is a small reflection, but in the actually, if you notice here in the NIR spectrum is where the actual higher reflectance happens. And also there are small spikes you can see in short-wave infrared. So what we are trying to do with this is based on this spectral characteristic of different objects, we are trying to identify the futures. And I'll go into the application part, how we are, how remote sensing helps in agriculture, for crop type identification. Also, if you want to understand the crop health, all this could be done using the satellite data. And I'm going to the detail. So this is just to show a satellite imagery example. What you're seeing here is basically a different agriculture fields. For example, here in the circle, what you're seeing is the field which have matured crops which are reaching the good health condition. So as you can see from this is a one snapshot of the satellite imagery of the fields, where you can see the difference between the fields also. Let me explain here. What you're seeing here in the brown patches are mostly those lands are not cultivated. That means there is no vegetation, the void of agriculture, void of cultivation. And where you can see the slight light green, where the crops are being shown maybe a few weeks older, and the dark green where the maturity is happening, and in the yellow where actually the ripening stage, the crops are reached ripening stage. Once it reached the ripening or harvesting is over, again the fields goes back to the initial phase where there is no crop, that is a brown phase. So how I'm this is based on my experience I'm telling with so basically the reflectance property of that Earth futures change over time, that we capture. Like we have a capability of getting this satellite data, like every 5 days we could able to monitor for any given region in the world. If one customer wants to monitor this entire cropping season, we have the capability to watch this season progress with the satellite data. So, and also in the recent years, there are a large number of satellite systems which are available for and launched for various different applications. Right now, the solutions which are capable of even monitoring at global level and country level, if you want to set up for So what you are seeing here right now is a vegetation change, which is happening for the year 2019 to 2020 for India. So this is done in the cloud computing platform. So what you are seeing in green is the typically kind of vegetation changes which is occurring in the entire country. And some of the recent advancements, so we have a very high resolution capability also. For example, what you are seeing here is in our India's Cartosat 3 satellite data, which have a spatial resolution of nearly 25 centimeter. When you talk about spatial resolution, basically it means the objects which are, so it comes down to the pixels, like our mobile camera phones, or you're talking about the megapixels. Something similar in the satellite data also, once it captures from the top angle. So it talks about 25 centimeters, the objects which are, the property of 25 by 25 centimeter square centimeter, that object can be detected from space. What you are seeing here right now is parked vehicles, and also, the lane marks and all these things you could able to identify from the satellite data. So before going into the crop analytics part, so right now we have a large amount of data, as in like we can call it as a big data. So as I said, like more than 2,000 satellites which are collecting data for the entire globe, and those data are archived. But extracting meaningful information from this satellite data, as well as the data which is being collected from ground, is a big challenge. That is where the artificial intelligence and machine learning tools comes into the picture. In SourceTrace, artificial intelligence and ML are like more hyped terms, but when it comes to the operationalized mode, where the machine learning takes place more than the artificial intelligence, for right now in the agriculture industry, for remote sensing related solutions. So basically, the machine learning is a subset of artificial intelligence, which have a defined set of algorithms that can be used to build models that can do predictive, and also as well as the classifications from the data. So basically, with this machine learning applications that can be broadly classified into, broadly categorized into, one is a classification, as well as classification or information extraction from the data, and the prediction from the data. So here I'll be going to show some of the use cases which SourceTrace using the remote sensing data, and also some of the machine learning techniques for classification as well as the prediction. So when it comes to the crop analytics from the remote sensing, there are three major areas which are crop area mapping and monitoring. So basically, in some customer, they wanted to understand, or a government body, they wanted to know what type of crop is being cultivated at a given state. Like, for example, for the state of Tamil Nadu, or like what is the portion of rice cultivated area, and what is the sugarcane cultivated area, and they wanted to know. But with the with physical surveys, and those are like resource intensive as well as more time consuming. When, as I said, when it comes to the remote sensing, where we have this capability of archived data, as well as we can monitor this larger areas in short duration. We have the technology here which we use to classify the crop types from the satellite data. And the crop advisory part and input minimization, and someone asked about the carbon footprint mapping and the sustainability of farms. When it comes to the crop advisory for our farmers, what we are trying to do right now is input minimization. Basically, the optimizing the inputs such as fertilizers and irrigation, reducing the water footprint, and also the carbon footprint. We are trying to do with we have the good repository of satellite data we used to monitor continuously, where we could get this variable rate of fertilizer applications as well. So basically, I'll show that information, like how we could provide this variable rate of application of the resources like irrigation or fertilizer usage to the selected portion, so we could reduce the inputs and also maximize the profit for farmers. And also in crop yield part, many insurance companies as well as the government, which need the information about how much harvest can be expected for the given season, that we could able to do with crop yield modeling as well as the crop yield prediction. So I'll go into the crop type identification. So right now, what you're seeing here is an crop type map of a Sangamner block. Basically, this is from Maharashtra, one particular administrative block where this study was piloted for mapping the crop types. What you're seeing here is different crops which is being cultivated in this particular block. So parcel level, you could be able to classify what type of crop, and also as well you can estimate the area, how much area in the given administrative block, how much area is under sugarcane. You want to query and get this information, you could be able to get this information from this particular data. So basically how we done this, so we used the machine learning algorithms. So basically it's a combination of decision tree as well as the support vector machine for classifying this crop types at parcel level. So we have completely automized this processing chain right now, because once the raw satellite data is received, there needs to be a lot of corrections to be done. Now, after that, we can, we need to train the model, and also you need to tune the model to get this accurate information. So right now we have a kind of developed this automated processing chain where we do the pre-processing as well as the model training and also information extraction. So another important example is farm boundary detection. Our customers are mainly more interested in farm digitization. So when it comes to the remote parts, the digitization of farm boundaries are much challenging, because for example, in Gujarat, the farm size are very big. In cotton farmers, they have more than 20 hectares and 30 hectares of land one individual farmer can have. But in Maharashtra and Tamil Nadu case, that might be smaller, maybe less than a hectare or something. But in some other countries also, we have a the global customers, they have a different needs, such as they wanted to digitize these farms, where the remote sensing can greatly help, with this machine learning algorithms and deep learning models. I have developed this mapping this and also the delineation of this farm boundaries from satellite data. Here we use very high resolution data, something which I showed as an example of 0.25 centimeter example, where that kind of a data is being used for detecting this farm boundaries. And as I said, we have a large, the archive of database. So we have data coming from different sensors from, different countries have various satellites operating for Earth information, Earth observation. So we have a good repository where we store the satellite data for any given region in the globe. Right now, what you are seeing here in the screen is a typical boundary of one particular region in Andhra, where you are seeing here is a red marked area is actually a single farm boundary. So this is just to show like how we are receiving this data. So with this minimum and maximum, what you are seeing is what is the development happening over the land in the given time period. Like every 5 days, we are capturing this data. What you are seeing here is from dark blue to yellow. The yellow is actually the maximum development happened in that particular piece of land of the progress of the crops. So with this continuous monitoring, we could able to identify, we could generate various insights like crop emergence, when the crop is emerged, and total crop area, and how the growth is progressing, and what state it is, whether it is a start of season or whether it is attained already the peak or which reached harvesting stage, and all this could be mapped. As I said, we could also identify the health condition of the crops based on the reflectance. If you remember the reflectance property of the vegetation, which I showed previously, the spectral reflectance curve could be used for in case of any sudden dip in the reflectance, that we could, from that, able to identify what kind of stress the crop is undergoing, whether it is a water related or whether it is related to nitrogen or some other important nutrient. That also we could able to identify. Sorry to rushing through because I have very limited time. I'll be finishing it in another 10 minutes.
Yes, fine, sir. No issue.
Yeah. This is an a crop analytics dashboard SourceTrace have developed. What you are seeing here is the blue colored boundary is actually a farm in which, like as I said, like every 5 days we are collecting this satellite data from different sources. So all these red dots you are seeing here in this timeline is basically represents one timestamp data available for that particular farm. So as I said, from that you could able to some customers they are interested to know which of the farms performing well. For example, for this Andhra, there are like 10,000 farms. Within this 10,000 chili growing farms, a customer might be interested to know which of the farms performing well and which of the farms not performing well. So these kind of insights, one way is directly through field visits, we could collect information, but through remote sensing, we have this advantage of getting this information with lesser time and also more efficient manner. So as I said, like continuously we are collecting this data through this the analytics platform we have developed. We could be able to flag the nature of the growth and what stage the crop has attained, and all these things we could be able to say, like from when the season is started and when it attained the peak of season, and once the senescence is stopped and there can be a steep slope can be observed. That's where we can say the crop is undergoing the maturity, and also the farms which are undergoing the harvesting stage. So this kind of the analytics can be given to the customers in a report form. So this is just to show the growth variability and nitrogen stress, how we identify. So right now what you are seeing here is the uncultivated land, the black boundary, which is representing a one single farm where there is no crop is being cultivated. That's why there is it's in brown color. But in the case of variable rate application, as I mentioned earlier, in order to reduce this input resources like irrigation as well as this fertilizer application, as well as also identifying whether the farm is undergoing any sort of stress. So right now what you are seeing here is there is a variation in growth of crop. What you are seeing in these pixels in the light green, also the white pixels, also the darker green. The darker green pixels represents there is a good growth as well, growth in the crops, whereas this within the farm there are like pixels which have light green and white, basically represents there is a variation in the growth. So right now what we know is there is a variability, and this could guide as a crop scouting information for field coordinators. Basically we flag this kind of farms and provide this information to field coordinators to identify the so kind of a reason for this kind of stress at farm level. And as well as for certain level of analytics, what we provide is whether if the growth variation is due to the fertilizer shortage, or because of the moisture stress, basically the irrigation, unavailability of irrigation. All this could, that also we could identify from the satellite data. Likewise, here in the right corner, what you are seeing is a nitrogen stress identified for one particular farm, where you are seeing the red region is basically the nitrogen stressed zone within the farm. So basically how we are doing this, the nitrogen is directly, which has a good a correlation with the chlorophyll content. So with the satellite-based, the spectral characteristics, we are mapping the chlorophyll content. From that, we are generating this indices called canopy chlorophyll content index that is used to identify the zones where the shortage of nitrogen. And there is a farm advisory services. Right now, as I said, these are like some of the requirements from farmers and also customers. They wanted to know, the weather alerts and also crop advisory services. So in case of any kind of a severe climatic event, the farmers should know this information much more, more advanced way. Like right now, we are providing this forecast for 14 days span. So basically, we have the good, the database of the farm, what type of crop is being cultivated, and with collaboration with ICRISAT and other agriculture universities, also we have developed this crop advisory database based on the existing condition. The rule-based advisory will be given to farmers, and also the weather information is also to be pushed to farmers via SMS services. So this is just to show another example of the impact assessment of crop damage, because many companies or government wanted to know the crop damage in case of any kind of a natural catastrophe or any event. How much area is affected, how much crop area is affected, and that kind of, and what stage is the crop, and all these informations are very crucial. So this is to show we had done an use case in Amphan cyclone during 2020 in West Bengal as well as in Bangladesh region. We have used the state-of-the-art microwave remote sensing technology for mapping this flood inundated areas as well as the standing crop. What you're seeing here in green basically indicates the standing crop on that particular season for the entire West Bengal. And the blue, what you're seeing is a flood inundated area that is mapped from satellite. So once we have this information, we could able to identify how much crop area is affected due to the flooding, as well as we know what stage is the particular crop. So in the prediction part, those are like information extraction, and also in the prediction part, in the pest and disease forecast, and also the modeling, the remote sensing, as well as this machine learning based models have a lot of kind of applications. For example, this study was done by ISRO for this locust, because in the last year there was a lot of threat because of this locust infestation in Punjab and Rajasthan, Gujarat regions, where so for pest and disease identification, so for the pests and particular disease which has the direct correlation with certain climatic conditions. So basically, with remote sensing, we able to get this various weather parameters such as humidity and wind speed, as well as the condition of the crop and the temperature. All these informations can be derived from satellite data. Once we have this satellite-based information about all these basic parameters, we could able to project and also model which of the regions which are susceptible to the infestation of a particular pest and disease. This can be the information can be transferred to the farmers to take necessary precautions to avoid any further damage to the crops. And crop analytics in crop yield, basically in crop yield part, it comes one way we do is direct estimations from remote sensing data. So farm level, we could able to identify the crop yield, how much tons per hectare can be produced for the coming for the current season. So basically, how this is done is again we use in the backdrop of various weather-related parameters such as radiation use. I mean the solar radiation, as well as the vegetation condition index, all these are combined, and we produce this biomass-based model for pixel level yield estimation. And we have also experimented this machine learning-based model for crop yield prediction in Telangana, which we have submitted for Telangana AI mission program, where for the 3 crops we have predicted the crop yield based on the weather parameters as well as the historical yield. When it comes to the machine learning model, the training and tuning the model is very important, where we have used the government data, and there are a lot of training, of course. So we have developed this machine learning model using the regression approach for random forest regression model was developed for identifying, the predicting the crop yield. So we have used sort of a satellite-based information as well as the weather-related parameters and historical yield information and historical area and yield information from government sources to predict the yield for 3 crops, that is gram, groundnut, and maize. Yeah, these are the things I would like to share with you.
Yeah.
Thank you.
Yeah, thank you, sir. Any question from audience to Vijayasekaran, sir?
Thank you, sir. Nice presentation. For requesting participant, do you have any clarification?
Sir, I have one clarification, sir. So normally for AI project, the deep learning model is better than machine learning model, like random forest. Is it true, sir? Because the accuracy will get more in the deep learning compared to machine learning model. When I saw your presentation, mostly you are using random forest and the regression based model. So why it is, sir? Yeah,
right, sir. Right. Let me answer this.
Yes,
of course, the deep learning models are better than the machine learning model. The problem with the deep learning models right now we are facing is the availability of data. For example, for example, for the crop yield prediction, also we are facing you need more data points to train the deep learning model.
Okay.
That's the reason we are right now more focusing on this machine learning based models.
Okay. Because of data availability, we are focusing on machine learning model. If data is available, you prefer to go with a deep learning than machine
learning. Yes, of course.
Yeah. Thank you, sir. Any other question from audience?
Audience participants? So I think chat box are there.
This on how you are protecting the confidential information. For example, every farmer knows what other farmers are doing. Can you check your chat window, sir?
Chat box, sir.
The data
down after people chat box.
Right. I can see the question.
Yes, sir. Send it to you.
Yes, of course, the confidentiality part right now, we have a ISO certified as well. We are maintaining this quality of the data protection while sharing only for the farmer knows the package of practices. It's not like they know how much the other farmer is earning, and all this information will not be shared. When it comes to the recommendation part, we will be sharing the package of practices. So that's how, yeah. Hope you want to add anything? Om, you want to add anything?
That's all right. I think this question is anyway for you.
Yeah. Thanks.
Thank you.
If you have any other question, you can unmute mic and directly you can interact with the work source person. Else you can type it in chat window.
Requesting participant, if you want any clarification, now time open for questions.
I think no question. I think, sir.
Yes.
Huh?
Okay, sir.
Yeah. So thank you, Om sir, and thank you, Vijayasekaran sir, for your time and shared a lot of knowledge. I think you have done a lot of things. You have not only, I thought it is initially process, no, it's only for blockchain. You are doing AI project similar to crop into different domain. So you want to learn further details, sir, we'll keep in touch with you and we'll invite for some other session also for our students and other things. So I'll request Venugopal sir to formally.
Sir, thank you very much, sir, on the behalf of FDP team. Really, Om, Routray sir, and Vijayasekaran sir, presentation nicely presented, sir. The more inputs we learn, since we also coordinator, we just seen how you are building, how you are taken up, other countries' project also, how you are implementing. Nicely you presented, sir, that especially Om sir, how like US based and some other African based countries, even Bangladesh, how tracking all this concept, how you explain, how you shown everything is clearly. I think all the participants also may enjoy that. But of course, Vijayasekaran sir also many things he explained, especially crop analytics dashboard, and of course crop advisory database that are very, very useful for all people who are working on research. So since on behalf of IAPM, we are always invite you, sir, for collaborative research work. Of course, collaboratively, we will invite for all other training sessions. Further, definitely we'll have a good relation with you, sir. On behalf of FTP team, I would like to thank to both of you, sir. Thank you very much, sir.
Thank you so much, all attendees, and thank you, Dr. Ganesh.
Thank you, sir.
Thank you, Dr. Ganesh. Thank you all participants.
Thank you, Vijay.
Thank you, sir. Thank you, Vijay. Thank you, sir. Sir, sir, as usual, tomorrow.
Tomorrow morning 10 o'clock, we'll have, as per the schedule, we have session. Afternoon, we have 2 to 3:30. There will be a presentation by Professor Nachiappan. After 3:30, we'll have test. Okay, and validatory function. Mostly test will be multiple choice question. So you have to switch on your camera. You have to write it in the session here itself. So we'll be recording your video and we'll be sharing with the AICT. So it will be 25 question, multiple choice question. Maybe we'll give 1 hour time, 3:30 to 4:30. Okay, so we are not sharing in WhatsApp group. Okay, so we'll be sharing only the YouTube
link only.
The test will be happen after 3:30 tomorrow afternoon. So 1 hour, 25 multiple choice questions.
Thank you, sir.
Any other clarification from any?
Already we shared in
morning. The resource person he was saying that he was wanted to share his email ID. Can you share that with us, sir, through the WhatsApp group?
Okay, I'll share it. Thank you.
Thank you.
Okay, then. If there is no question, we'll stop here. We'll meet tomorrow morning at 10 o'clock. Okay. See, please try to interact. We are spending a lot of time to bring good resource person. Only some 1 or 2 faculties are keep on interacting.
Make use of it. Really, we'll have more collaborative research work also.
So bringing spending a lot of try to be interactive. Some people size are under interacting, but requesting other faculty members also please interact.
Very few only
learn from each other.
Yes.
Okay, so with this we'll stop here. Tomorrow we'll meet at 10 o'clock.
Okay.